Good morning, sir.
Okay, so as I told you in the previous class that we have completed basic thermodynamics part, and now we are entering into a totally different subject. It relates with the heat, but more often the transient in that particular state of heat, how the heat gets transferred from one object to the other, what are the conditions prevailing at. So all those things we will be trying to discuss from now on. So it is entirely a new subject from now on. So it's called as the heat transfer. And the heat transfer, as I previously mentioned, so we'll be discussing the basics of heat transfer in the module number 3, okay, and in depth about conduction in module number 4, and in depth about the radiation in module number 5. So there completes your syllabus. So from now on, the syllabus is a little bit easy because we have vomited this thing, the convection part. Okay, so I do not want to just burden you out. So let us make it simple from now on. So heat transfer for the module number 3. Module number 4, we'll go with conduction. Module number 5, we go with radiation. So the leftover topics could be some parts of applied thermodynamics, which is in module number 3, which discuss about all the whole subject is being incorporated into a half of your module. Applied thermodynamics is a big subject, and that subject has been cut shorted and incorporated as a half of your module in module number 3. We are vomiting that. Moving to the module number 4, we are vomiting the free convection. Model number 5, the post convection part you have taken out. These are the things. Now, after completing model number 3, 4, and 5, still if you have time, we will go with the convection part, that is free convection and post convection. If yet we have finding time, then we will go with the applied thermodynamics part. Personally, I feel that applied thermodynamics part is more interesting to explain, more enjoyable to learn when compared to all the 5 modules. Let us see how it goes. Okay, shall we start heat transfer from today?
Yes, sir.
Okay, so this particular class will be of more of theory in nature. So it is just a discussion. Already 50 to 60% of the concepts you might be knowing in your basic science, but we will have an in-depth revision of those topics now. Okay, let us start. So heat transfer is nothing but the transmission of energy from one region to the other region because of the presence of the temperature gradient. So there must be a hot body like this, there must be a cold body like this, there must exist a temperature difference. That means if this is at the temperature T1 and this is at the temperature T2, definitely T1 should be greater than T2 so that the heat gets transferred from the hotter body to the colder body. So this particular transformation of heat is nothing but the heat transfer. And this occurs through conduction, convection, and radiation. So all these 3 modes we have already discussed in work and heat, I guess. So there was a bit of heat transfer mechanisms in your syllabus, in your module 2. The same thing has been repeated here. So what is conduction, what is convection, and what is radiation? I expect from you guys. So what is conduction first thing? What is conduction? Yes. Benoy. Fahad Abdul.
So the process by which electricity or heat can
Yes,
be
sir.
like transmitted through an object.
Or an object. So you can say it is a more of a molecule to molecule heat transfer. So you can just read the definition, Gaurav. Can you just read this?
From
Gaurav,
conduction, sir.
Yes, sir.
ah,
Yes, sir.
read this.
Con-
Conduction is the heat transfer.
Conduction is a
conduction is the heat.
Yes, Gaurav, you read it. Fahad, I will give you a
Con-
chance. Okay.
con-
okay, sir.
conduction is the heat transfer of
Hmm.
heat from one part of the substance to another part of a same substance,
Yes, from one
or
substance to
from one substance to another in physical contact with it without the
uh, appreciable
appreciable displacement of molecules forming the
forming the
substance.
substance. So that is what if there is an displacement of the molecules, then it will turn into the convection mode of heat transfer. Where if there is a hot body like this, okay, if there's a hot source like this is a hot source, and if there is a cold molecule, what happens to this cold molecule is it will move to the hot body. Okay, and this is getting transferred. There it is. Okay. So what happens to this cold body is it's literally moved towards the hotter source like this. It gets moved towards the hotter source and it collects the heat. Uh, is the screen visible, guys? I have a doubt.
No.
Now, sir.
No, right? Ah, now it is fine, I guess, right?
Yes, sir.
Ah, so in convection, what happens? Let me go faster about this. We have already explained it. So in the convection, your molecule itself just move towards the hotter molecule. When it moves towards the hotter molecules, it gains the energy. It gains the energy from the hotter source, and then it moves away from the molecule. Okay, that particular process is known as a convection, where there is a literally movement of your molecules. But for the conduction, there has to be a physical contact between the molecules or a substance to transfer the heat. And how this transfer mechanism actually happens? In the solids, most of the things happens by the lattice vibration. Lattice vibration is nothing but adjacent molecules just particular molecule just vibrate and transfers its energy to the other molecule, and this molecule vibrates and transfer energy to the other molecule, and such type of transfer is known as a transfer by the lattice vibration, by the transfer of free electrons. And this particular thing can be happened where the free electrons gets transferred from one molecule to the other molecule, thereby transferring the energy. In cases of gases, the heat conduction is simple. The kinetic energy of molecule is a function of temperature. These molecules are in continuous random motion, exchanging energy and momentum. So you know how the heat gets transferred in the molecules. It has a random motion. Because of the random motion, the heat gets transferred within the system or within the molecules. And the molecule, all things the same thing. Next is convection. Convection is a heat transfer within a fluid by mixing one proportion of the fluid with another. So convection is possible. Rather reading myself, Fahad,
Yes, sir.
just read this.
From convection, sir.
Yes,
Convection is the transfer of heat within a fluid by mixing of one portion of the fluid with another. Convection is
transport of
possible.
energy. So, Yes,
Convection is possible only in a fluid medium and is directly linked with the transport of medium itself.
medium itself.
Convection
Yes,
constitutes the macroform of the heat transfer since macroscopic particles of a fluid moving in a space cause a heat exchange. The
exactly.
effectiveness of heat transfer by convection depends largely upon the mixing motion of the fluid.
Okay. So effectiveness in the sense if there is hot water here and I want supposed to heat it. Okay. So it is said that if you place a spoon or whatever utensil and just stir it and cause the motion within the water, there your water gets heated fast. Have you heard about it? Even in your cooking also, it gets evenly heated. So increasing the motion of the molecules can increase the convection rate. Okay, that is what he's saying in the point number three. Okay, and all those are two forms of convections are there. That is, as I explained you just previously, if I induce a force in the convection process, that means I am using a stirrer to stir the water inside the beaker or whatever it is, then that particular heat transfer is known as a forced heat transfer, forced convection heat transfer. I'm not using my stirrer and not using my spoon, just I'm supplying the heat and I just leave the system as it is. Okay. Then the convection happens, and that convection is known as the free or natural convection. Got it? Any doubts in this?
No, sir.
Okay. Next, coming to the radiation. Radiation is a heat transfer where there is completely different from the conduction and convection, where the intervening medium itself is not required. You do not require a molecule to transfer heat from one region to the other region, nor you require a substance, nor even you require a atmospheric air. The speciality of the radiation is that it can transfer its heat even in vacuum through electromagnetic radiations. And these electromagnetic radiations, preferably they are infrared rays. Can anyone just say me the spectrum, electromagnetic spectrum? Hope you have learned and uh, second PU's times or even in the physics also, engineering physics. Electromagnetic spectrum, it has so many waves starting from the radio waves to gamma in order of their decreasing wavelength and increasing frequency. Anyone remember that? Just to enhance your knowledge. It is not there in the syllabus anyhow. Just to enhance your knowledge. That's it. Anyone knows about it? The one, Karthik, Amita, Mr.
No, sir, don't remember.
No, sir.
So it starts from radio waves. Next comes your microwaves. Next comes your infrared. Next comes your visible light. And there is a big gear that is violet, indigo, blue, green, yellow, orange, and red. After that comes your UV rays, next X rays, next gamma rays, next cosmic rays. All those rays for that electromagnetic spectrum. Anything recalling? Okay, have have that basic physics and basic maths. Very important physics and maths. Okay, just have a basics of this. Okay. Let us go to the Fourier law of heat transfer. This is very important. And from this particular law of heat conduction, and this is a law which is governing the conduction. So Fourier law is a basic law through which the conduction process is being governed. And this particular law is so important that it will cover more almost 80% of your problems from your module 3 as well as from your module 4. Keep this in mind. From your module 3 as well as your module 4, all the problems you will face only on the Fourier's law, most of them. Okay. So that's how important it is. And it is an empirical law. What do you mean by an empirical law? Empirical relation, empirical law. What do you mean by that? Sagar.
Yes, sir.
So what do you mean by empirical? Have you ever heard about it?
I don't remember, sir.
Okay, fine. So empirical relations are those relations which do not have a mathematical proof, just by experimental observations, looking into the readings which they obtain, they form an equations, and such an equation is known as an empirical equation. Usually, empirical equations are derived from empirical laws. Too much of theory not required. Now, directly we shall get into the law. Law says that the rate of flow of heat through a simple homogeneous solid is directly proportional to the area of its cross section. Keep this in mind. Whatever he says, I am just writing here. Uh, the rate of heat transfer, I will take it as Q, which is directly proportional to the area, he says. Area, which is right angle to the heat flow. That means if the heat flow is happening in this particular direction, and the area I have to take, which is at exactly the right angle to the heat flow. So that particular area, it is directly proportional amount of heat transfer. Second thing, right angles resistance, and to the and to the change of temperature with respect to its length of the pipe. That is nothing but the temperature gradient. That means Q is directly proportional to the change of temperature. Change of temperature is nothing but the change in the temperature from hotter body to the colder body, dt. That is your change of temperature, and it is inversely proportional to the distance between them. That is your dx. So dt by dx togetherly they are called as the temperature gradient. Okay, dt by dx is called as what? It is called as temperature gradient. So same thing he has given here. You can observe Q is a heat flow through the body per unit time, that is in watts. Okay. A is the surface area of the heat flow perpendicular to the direction of the flow, that is in meter square. dt is the temperature difference of the faces of the block. Just remember temperature difference. That is, after all this, we shall see further. Okay, so just remember dt is the temperature difference, and dx is the thickness of the body in the direction of flow. What is the, if there is a block like this? I'll explain, that is not a big deal. Now, if there is a block like this, the distance, this particular thing is dx, okay? And if it has an area like this is area like this, area A, okay? Now the heat is flowing like this, okay? This particular surface is at the temperature T1, this particular surface is at the temperature T2, okay? Now, so how do you calculate the heat flow? So Q is equal to A into, okay, dt, in the sense it is T1 minus T2 divided by dx is nothing but this particular length here, L. So if you want to remove the proportionality symbol, you have to incorporate a constant. So that particular constant is nothing but k into A into dt by dx, right? So this constant, which is incorporated to remove the proportionality symbol, is known as the thermal conductivity of the material. So the K values you need to remember for most of the engineering materials, like for diamond, it is highest. The thermal conductivity value usually specifies how your material would conduct the heat. If the thermal conductivity value is higher, that means it is more of a conductor. That means it allows the heat to pass through. If the thermal conductivity value is lower, then it does not allow the heat to pass through, and it becomes a resistor or an insulator. Okay, and that is how it is. So most of the engineering materials, you have to remember highest thermal conductivity value is on the heads of the diamond. So diamond is of containing higher conductivity around 2400 watt per meter square, I guess. 2400 around. Next comes your silver, which is of 480. Next comes your copper, 385, and next is steel, which is 18 to 35. Water is around 8, I guess. Air is around 1.2. Freon, which is insulator, you might be observing in this thing, refrigerators and all. It will be covered with a woolen-like material, white woolen-like material. That is nothing but freon. That is asbestos. All these have 0.082, something around like that. So Hope I have a table for that. Okay, so that is your thermal conductivity of the material. And here are the different values of thermal conductivity of the material. So thermal conductivity of the material depends upon the following factors: how the material is structured, density of that, moisture, pressure, temperature, all these factors, the thermal conductivity would be dependent. Okay, the initially you have all the values. Remember few of the values. Diamond has been not been given, I guess. Diamond is the highest, it has around 2400. Okay. Any doubts? Anything to be discussed more here? Anything? The units of thermal conductivity is what? Watt per meter Kelvin. You have to just remember this. So what is the units of thermal conductivity? It is watt per meter Kelvin. Okay, remember this. Any doubts here? Any
No,
doubts?
sir.
No, sir.
Okay, fine. So next is your thermal resistance, man. You have this analogy, right? If okay, there is a resistor, right? Current, current, and there is a potential difference. Okay. Now, if I want to push this current through a resistor, your resistor offers some resistance for the flow of current. And how these three parameters are related? How these three parameters are related?
V is equal to IR.
V is equals to I divided by R. Correct? Correct?
Is it I is equal to V
I
by R?
into R, sir.
Sir, I is equal to V by R.
I want answers from human. What is the correct answer then?
I is equal to V by R.
I is equals to V by R. Now it is correct.
Yes, sir.
Yes, sir.
Sure.
Yes, sir. I
Yes.
is to
100%
V by
लॉक
R.
कर दिया जाए.
Yes,
Yes.
sir.
Fine. See, what is I? I is the amount of current that is flowing. Next 10 to 20 seconds of explanation is very important. Just listen it. Okay, I is amount of current flowing. V is the potential difference between the two ends, which drives the current in. R is nothing but the resistance offered by the conductor. Similarly, I analyze this with respect to a heat transfer now. Okay, what I'm doing, I am analyzing this particular thing with the heat transfer. Okay, now I is what? I is the amount of flow of current. Now I take Q to be amount of heat flow. Okay, that is equals to V is what? The potential difference at the ends. That means I take here as temperature difference. That means it is dT divided by R as the resistance offered. I'll just take as resistance. Okay, just a second. Okay, so yeah, where was I? Ah, so I is the amount of current which is flowing. Okay, and I similarly analogy I am making with respect to the heat transfer. Here I take Q to be the amount of heat flowing. Now, V is the potential difference which is exhibiting at the ends. So here I take the temperature difference at the ends, which is Tt. And R is the resistance which is offering for the flow of current. And here I take R to be the resistance which is offering for the flow of heat. Right? Now, teaching board. Okay, so in this analogy, you have got Q is equals to dt divided by R. Okay, dt is nothing but the temperature difference. For a plane solid like this, for a plane solid, your resistance value is L divided by Ka. You have to remember this. Okay, anyhow, we will be comprehensively understanding this in the meanwhile. But just remember the resistance for the plane solid is L divided by Ka. Substituting it, Q is equals to dt divided by L into, shall I take a different thing? L divided by Ka. So what happens? Q is equals to, if you transfer Ka dt by L is nothing but your dx. Again, it's nothing but your Fourier law. Okay. So this is the concept of the thermal resistance one. So how you have your electrical resistance, the same analogy can be made for a thermal system. There you will be having the electrical resistance, here you will be having a thermal resistance. So that the value of R, that the value of what is R here, R is nothing but the thermal resistance, not the electrical resistance. It is given by L by Ka. Any doubts in this? Any doubts here?
No,
No,
sir.
sir.
Okay. The reciprocal of thermal resistance is called as the thermal conductance. The reciprocal of thermal resistance is also called as thermal conductance. So all these systems will be analyzing very neatly when you are solving the problems. The problems are really interesting and easy. Yes, here it is. The problem. Calculate the rate of heat transfer per unit area through a copper plate of 45 mm thick. So what is the thickness given? 45 mm thick. That is nothing but your L or the dx you can say. Okay. Next, one phase is maintained at how much? 350 degrees centigrade. That is your value of T1. And the other phase is maintained at 50 degrees Celsius, which is your value of T2. Now, the thermal conductivity value K of the copper is how much? It is 370 watt per meter degree Celsius, degree Kelvin or degree Celsius. Whichever is given, you have to take the same thing. Suppose if your K value is in degree Celsius, then you just keep the T1 and T2 values in degree Celsius. If your K value is in degree Kelvin, then you convert this to Kelvin and Kelvin. Clear with this concept?
Yes,
Got
sir.
it? If your K value is in degree Celsius, convert the dt value also should be in Celsius. If your K value is in Kelvin, even the dt value should be in Kelvin. Take care of that. Okay. Now, what you have to calculate? You have to calculate the rate of heat transfer per unit area, he says. Per unit area in the sense, I can take the value of A to be 1. Yes or no? Unit area, or at the end I can just make it as per meter square. Okay. Now the temperature difference is what? T2 minus T1, that is 350, and minus is already there will be, if you take minus here, it will be T1 minus T2 directly, or else it is T2 minus T1. Always it will be in a negative, the value whatever you get, it will be negative. Why? Because you're transferring the heat. The heat is getting lost from one surface to the other surface. Okay, so it is 50 minus the minus 350. Next, the thickness of the copper plate is 45. Thermal conductivity is being given. Use the Fourier law, which says Q is equals to minus Ka dt by dx. Substitute the values of K, K by, you can, since A is not given, you can transfer to the other side. So Q divided by A is nothing but the small q. Small cube, the units of cube is what? Unit of cube is watt, and unit of small cube is watt per meter square. All these are just notations, man. Okay, if you transfer cube to the other side, it is just q by a, so it is small cube, so minus k into dt by dx. So substitute the value of k, substitute the value of dt, substitute the value of dx, you'll get the value of cube in watt per meter square. Any doubts in this problem? Anything you did not understand? Yes?
No, sir.
It's easy problems, man. All these are very, very easy problems. Let us look into another most problem. The plane ball is 150 mm thick and its wall area is 4.5 meters square. That means he has given the value of dx, which is thick, and he has given the value of a, the area. If its conductivity is given, he has given the value of K, which is 9.35 watt per meter degree Celsius. And surface temperatures are 150 and 45, same problem, no difference. Heat flow across the plane wall, same thing you have to find if there is a plane wall like this. Okay, the area of which is given as 4.5 meters square. The length or the thickness of this is given as 150 mm. Okay. The surface temperature here at the surface 1 is 150 degrees centigrade, and the surface temperature T2 at the second phase is 45 degrees centigrade. So the heat gets transferred from here to here. So what is the rate of heat transfer? You have to find it out. Same problem. And the temperature gradient in the flow of the direction. That means you have to find the dt using a Fourier law. So k is equals to minus ka dt by dx, that is equals to ka into minus 105 divided by 9.35 is your thermal conductivity, 4.5 is your area. Substitute, will get the value of Q. Temperature gradient in the sense the value of dt by dx you have to find out. So once you have calculated the value of Q, Q was nothing but what? Minus Ka dt by dx. The whole of this term you have to calculate. You know the value of Q which you have just calculated here. K is given, A is given. So just calculate what is dt by dx, which is minus 700 degrees Celsius per meter. Any problem in this problem? All these are simple problems. Any doubts? Any points that you did not understand? All right.
No, sir.
Clear, right?
Yes, sir.
Okay. Are you feeling boring today? Most of you are not responding. The reason, man.
Everyone was expecting Diwali holidays.
That you get tomorrow, right? Tomorrow is a Diwali holiday. That will get tomorrow. Okay. All are in Diwali swing. Festival mood.
Kind of, sir.
A kind of. Okay. So. Okay, man. No problem. We should take some in another class. We shall end the class now. Okay. This is the conduction. Is the radiation concepts are combined transfer. And there is a good news for you, I guess, right?
What, sir?
Hope everyone got it by now.
No, sir.
No?
No, sir.
So, how many of you have played PUBG? No? I think PUBG is being on from today.
Yes, sir.
The Indian version is being launched, I guess. Adarsh, Abdul Rahiman.
Yes, sir.
Okay. Abhinav,
Yes, sir.
Adarsh.
Sir, any updates regarding opening of the college, sir?
Opening of the college as per Ashwat Narayan's instructions. He said that final year classes has to be engaged offline and all the remaining things, that is the third year, second years, and the first years can continue online itself. So most probably 99% your classes might start
On 17, sir.
on 17th, I guess, most probably. If it starts with statement, I feel as such because all online classes is really hectic for you, for your eyes, as well as for me. Ahmad Reza, Akshay Arkutian, Amit Yaslihari,
Present,
Sir,
sir.
Adarsh.
Adarsh, you are there.
Yes.
Adarsh, okay, fine. Ahmad Reza, Akshay Arkutian, Amit Yaslihari.
Present, sir.
Next is Amrit,
Present, sir.
Anvit, okay. Ashwin K.A.,
Present, sir.
Ashwita,
Present, sir.
Kundan C, Benoy.
Present, sir.
Anvit, I have called to serve. Yeah. Fahad,
Yes, sir.
I think most of you are leaving as soon as you answer attendance. So before you leave, let me wish you a happy Diwali, man. Stay blessed, keep smiling always. Okay.
Wish you the
Gaurav,
same, sir.
Happy Diwali.
Thank you,
Same to
sir.
you, sir.
Gaurav, Gautam HS,
Present, sir. Gaurav.
is Javel,
Present, sir.
Karthik,
Present, sir.
Sir, Faizan present.
Faizan. I have not called your name, man. Wait. Muhammad Fazil,
Present, sir.
Muhammad Sihab, Muhammad Tausif Ali,
Present, sir.
Waz, Yan Suraj,
Present, sir.
Nafa, Namita,
Present, sir.
Present, sir.
Narpan, Niharika, Nishchit,
Present, sir.
Nitin George,
Present, sir.
Sir,
Miss Niharika.
my attendance was not heard, sir.
Okay, I have marked it.
Sir, Chandan present.
Omkar, Prathan Jain,
Sir,
Present, sir.
Chandan present. I had network issues. I had to log out.
and then C. Okay, mark. Suvarna,
Present.
Rajat Rai,
Present, sir.
Dakshan K, Ramdas, Ranjat, Faizan, Dakshan K, Ramdas, Ranjat, Gaurav. Gaurav. How about you, man, Gaurav? Prathan Jain. Okay, how marked you, Prathan? Dakshan, Ramdas, Ranjat, Shabat,
Present, sir.
Mr. Sagar,
Present, sir.
Hazad Abdullah,
Present, sir.
and PC,
Present, sir.
Vijay, Shetty Tejas, Ravan Kumar,
Present, sir.
okay, Ravan Kumar, Sriraj, Saurabha,
Present, sir.
Saurabh, okay, Sumant, Varun Nessel, Vignesh Para, Amit Sangol,
Sir, Amit Sanguli, sir. Yes, present, sir.
okay, Nilesh Markal,
Present, sir.
next is Prajwal Hekade,
Sir, present, sir.
Rohan Pradeep,
Present, sir.
Mohammad Amin, Adarsh P,
Present, sir.
Amin, and Numanas Saddiq.
Sir, Muhammad Amin.
Okay, Mohammad Amin is there and Numanas Saddiq, right?
Present, sir.
Okay, okay. Happy Diwali, Niharika, and everyone. Happy Diwali. Always be enlightened, be happy. That's most important. Okay. Take care. We shall meet after the festival.
Wish you the same, sir.
Yeah. Thank
Happy
you.
Diwali, sir.
Thank you.
Happy Diwali.
Thank you.
Happy Diwali, sir.
Thank you. Thank you.
Happy Diwali, sir.
Thank you.
Happy Diwali, sir.
Nice ringtone, sir.
Thank you, man. I'm just a fan of his attitude, nothing else. The whole movie carries only because of his attitude, the way he acts. Okay.
Bye, sir.
Bye bye. Take care.
Bye, sir.